Hey there, folks. So, last episode we set up hunger and thirst health damage for when you're dehydrated and you're starving. We added in an exhaustion component for when you have used up all your stamina that blocks your health stamina regeneration. And we went through and just did some cleanup with our stat line. So, as I mentioned, in this episode, we are going to be covering the save game component, or at least starting to cover that. And the reason why I say that is your save game component is actually something that you end up working on throughout the lifetime of your project, pretty much, up until you're on just the final bells and whistles point where you're just making everything look nice and you're not worried about any additional data that needs to be saved. So with that, the first thing we need to do here is actually go over to our content browser. Let me bring that into screen here. So we are going to actually be adding 3 classes right at the start of this episode. So the first one we're going to be adding is the save game. And this one is a fairly simple class. We're not going to be doing much to it once we do get to that. It is just very basic class here. And for that, I'm going to be adding this to the game folder. Again, folder structure is your own choice. I like to try and keep things as organized as possible. So we're going to create that. And Visual Studio here is going to request that I reload. We're going to wait until we're done adding all 3 of those files though. And as you can see, I launched the editor directly. I didn't do it through Visual Studio. So I'll hop back over to, oh, it's not letting me right now. Let's hop over. Nope. Let's try minimizing this. There we go. So while all this loads, I'm actually going to run through a few things with you guys, just so you have a better understanding of the direction I'm going. The first thing we need to think about is how we're going to be identifying all of the different actors that are going to be having their data stored. You could go through and create a save entry for every actor you add, and in smaller games that may work. You don't need to worry about any form of unique identifiers. If you can say have 20 actors that you need to worry about the data, and that's it. No, we're not going to reload that. We're going to go back to project. Get live coding up here. So with that, the other option you can do is you can add in a unique identifier of some kind per actor, and that unique identifier is used to just that, identify the actor. Now within coding, for anyone familiar, there is something called a GUID. Let me just pull up some information on that, just because I like to be precise with my information. So with that, a GUID is a global unique identifier. It is a 128-bit text string that represents an identification. And it looks something like that. And this is going to vary, depending. And then just quickly, how many GUIDs are possible? I'm not going to try and actually pronounce that number, but for a rough idea, hundreds, thousands, millions, billions, trillions, and then I can't remember, septillions, nongillions, something like that. It's a ridiculously large number. So this right here is actually a very good solution for a project that needs a dynamic number of actors. It's going to change. It's going to go up. It's going to go down. Things like that. So first off, right there, that is something we're going to want to use to identify all of our actors. And actually, while this loads, I'm going to move this off to one side and open up Visual Studio so I can give you guys a rough idea of what I'm talking about. Reload all. We can do that multiple times. Well, actually, I say that, and live coding has just finished. So we're going to go back and add in these other ones, and then I'll keep talking. So back in the content browser, we're going to go right-click again. And the next thing we're going to do, I dislike that sometimes. the next thing we're going to do is create a game instance. Now, for anyone who isn't familiar, what a game instance is, it's a singleton. And again, for those that aren't familiar with what a singleton is, what it is it is an object that is created once and can only be created once. And in the case of the game instance with Unreal Engine, it is something that is created as soon as the application, your game, is ran, and it is there until the very end when your game shuts down. And it's never deleted or destroyed in between those 2 points. So any information stored in there is retained when you move from level to level and things like that. And that's a perfect place to store dynamic information that you want to be transferred from one level to another. And it's also just a good place to store things when you need to store that information. So we're going to create that class and bring back live coding. This should actually go pretty quick. Visual Studio wants to reload again. We'll say reload. It's not an issue. Go back to Unreal. Bring up the live code. Anyway, so I'll just keep talking while all of this loads because there is a lot to talk about in this episode. So, as I was mentioning, the GUID is a perfect unique identifier to use for your save game. And we'll be covering adding that in either at the end of this episode or actually at the start of the next episode, in a way that you can guarantee you're going to be using a unique GUID. So the next thing to think about is, well, what sort of information, and this is why I was going to Visual Studio actually, so I'll bring this back up. What sort of information are you going to want to include? Let's just do a bulk comment here. So you're going to want to include, we'll just think about the player character to start with. You're going to want to include their location, their rotation. Depending on your game, you may want to include scale. Well, that's an easy one. All three of those can be covered by a transform value. And then there's going to be other things like you're going to want to include their health, stamina, in my case, hunger, thirst, because you don't want the player to save the game, reload the game, and all of a sudden their health, stamina, hunger, thirst, whatever stats you've got, come back as full. Well, that's a glitch. It's very easily exploitable and not something you want. Then there's going to be other things like, okay, you want to store their inventory, any money they may have, any experience, things like that. So, and this may just be you play a character. Let's take, for example, the game I'm hoping to make here. I'm going to have harvestable trees. So, well, what information are you going to want to store for that? Well, there's a lot of different things you can store for that, and it all depends on how big you want your save games to be as well. Like for harvestable tree, in my case, I'm just going to be including was harvested a value, and that literally knows, like, we'll say I haven't done the exact debugging and testing on that, but let's say it's 3 hits with an axe and then the tree comes down. Well, if you hit it twice and then you save your game and you reload your game, you're still going to have to hit it 3 times. I'm not going into including the number of hits because like that is, you're starting to bloat that. And just imagine you had a player who wanted to try and bloat your game save, and they go around and they figure out that, oh, if I hit a tree twice and save, it adds that. And then they go and just do that to every single tree in the game. You could eventually end up with a save file that's corrupt just from the sheer bloat. And these are things you need to take into consideration. So anyways, I'm going to clear this out because this isn't actually relevant for the game instance. Are we done with the live code yet? Yes, we are. All right, so back in, we're going to add that third class I was talking about. And I forgot to add this into there. Cannot move. So I will be fixing that later on. We can deal with that at another point. The third thing we're going to add is actually an interface. So we're going to scroll all the way down here. Unreal interface, your interface object class to be implemented by other UObject based classes. Interface, going to put that in the interface folder, and then save actor interface. Now, I'll go into a little more detail of why we're creating this interface a little further along once we start getting into some more of the actual code work. But for those who don't fully understand what an interface is, it's a way to say, okay, I have this interface. I have, we'll say, 4 specific functions in there. And it's a way to have any class be able to talk to another class and know it's going to have these 4 functions that it can do. So again, it's hard to explain. We'll cover as we go through that. So anyways, we're going to create that. Now we have those 3 files created. We're going to reload there. And we're going to, in here, in your Solutions Explorer, you can go through and you can move these files into the folders, but that is only going to affect it here within Visual Studio. It's not going to affect it in the editor. What we need to do, and actually let's close out of the editor here so that we don't have this running. We can do these other changes. What you do need to do, so let's go open folder and file explorer, bring this over. So we need to go through here into your source, go through, and you can see here in the public folder we have our game instance, which we've already got open, and apparently I double clicked that, which is not what I was trying to do. What we want to do there is move this folder into game, go into private, move this into game. Now in here we're going to have to close out of the game instance files, and what we actually need to do, because they're no longer there, I found the easiest way to do that, you just select both of them and remove, and then you just add them back in. So add existing source. Which one am I on? This is the private. And then public game instance. All right, so now we've moved those in, we've got those back. You can see we can open them up. They're now present. What I like to do after adding in these classes, even though the live code editor worked, and you guys can't see me doing air quotes here, worked and set everything built, that is just runtime memory. It gets wiped as soon as we close the editor. And now you can see in here we have a build error. This is likely from how I fixed something. So gameinstance.cpp. Oh, that's because we are missing. There we go. We are missed fixing that file path. So let's try this again. So this is the other reason why I said to build, is we move some files around. Folder paths may not be correct. There we go. We fixed it. But anyway, so now we've done that. Let's go through what I was talking about at the start there. This will eventually fix itself. This is just IntelliSense being slow. So we'll start by getting this set up in here. So as I was mentioning, you want to start with a GUID for your actor ID. And in Unreal, they actually use, I'm going to have to wait for this to load for that. Is this one that works? Let's see. Yeah. Well, what we can do while we wait for IntelliSense to catch up, actually we can start by defining the struct that we're going to use for our save data. So as I was mentioning, you're going to want to save a bunch of information for your individual actors. So I'm going to start ustruct blueprint type. And again, this is so if we need to do any logic in a blueprint, we can still use the same information. Just because this is a C++ project does not mean blueprints are not going to be used. Yeah. Save actor data. Data, however you want to pronounce it. I'm not going to get into phonetics. So, and then it's the generated body ustruct. Again, you can use whichever one you want. I just use ustruct because it is for code clarity. Now, in most cases, you're going to want to use private variables with getters and setters. But because this save actor data is well, it's short-lived. So I was trying to think of the right term to use there. Personally, I've never gone as far as worrying about putting it as a private with getters and setters, just simply because it's short-term memory. And honestly, if somebody is going to be putting in the effort to hack your single-player game to this extent, then they're going to do it one way or the other. So, and again, to that point, actually, this is only because this is a single-player game. There's zero intent for online multiplayer, things like that. An online game, you're going to want to add in a ton of additional security and anti-hack measures, and it's just the way that is. So, but anyways, so in here, let's say we want it to be a public in this case, property visible anywhere, blueprint read write, because as I said, we want blueprints to be able to modify these if need be. So the first thing, as I mentioned, f transform, actor transform. The next thing we're going to want, and this is for your serialization, and it helps keep things as automated as possible within the save. There's going to be things that can't be serialized for one reason or another, but we want a T array of uint8, and this is your byte data. And then we want, as I mentioned, for things like a runtime spawn, like say you've got a spell that you've got a fantasy game summons a fire elemental, and you save your game while that fire elemental is out. Well, you're going to want to know you need to respawn it. So bool was spawned equals false. That's one we can set there, because the majority of actors saved are not going to be spawned, so you can give that a default value. And then this is also, again, for that you need to respawn an actor that was created at runtime. You also need to know its class. So uClass pointer actor class. Now there may be some additional data you need to store in here as well. You could need to store individual components. You could need to store additional information that's not captured as part of the serialization. With that, and I know from experience with this project, there is additional information that's not saved. We will be adding in some additional storage classes to the bottom here. But for now, this is the very basics we're going to be starting with. So as you can see, I've added this into the save actor interface header. And the reason for that being is this is going to be exposed to every single actor that's going to be using the save game functionality, or is going to be interacted with save game functionality. So this is putting it in a place where every class is going to know about it, that needs to know about it. You could go through and add it to its own data type and then start including that. I just found I like to reduce the number of includes where possible. It also saves with a lot of recursive includes. Thankfully, like by default, you get pragma once in here. Personally, I'm not a fan of the pragma once, but it does what it needs to do. So anyway, so we've got this here. That is our basic data structure for storing our save game information. I'm going to do here, I'm just going to grab this include. And we are going to go back to our game instance. So our game instance header here, which is still not wanting to fully load. So I'm going to throw this here. And okay, because we move this around, there might be some issues here. So what I'm going to do is I'm just going to quickly pause and reload Visual Studio. All right, so even reloading it didn't work. So just for the sake of ease, because I want IntelliSense to work here, we're actually going to go through and recreate that. So open folder in File Explorer, go through. And this is just because, again, I opened it in, or created the game instance in the wrong folder. Tried moving it, and in this case, not interface game instance. So in close of that, we can remove it from here. We can build. But yeah, this is all because I created it in the wrong place. So you guys will have been seeing it in every episode. I end up doing something silly, and I keep those mistakes in just because, well, I want you guys to see, yes, these are mistakes. These are how you can fix them. So I will be back once this is built, and I will have the editor open just so we can recreate that file. All right, folks, we're back here in the editor. So we'll just quickly fix what I had messed up. So we're going to go into the game folder just for certainty. New class, and this is the game instance that we're creating. Game instance. You can see we're in the game folder, and just give that the name TF game instance. So we're going to create that class. Visual Studio is going to ask to reload. I'm going to reload all. It's now in our content browser, Solution Explorer. I'm actually going to get rid of the live coding. We're not going to do that. And we're going to be closing out of the editor right away as well, because we don't need to be in here. So when the editor actually responds, come on. There we go. Okay, so as I was mentioning, we have our struct here, which is going to be used to store actor data. This is pretty basic. But what we're going to do here, just as I was trying to do, quickly grab this header file. We're going to go over to our game instance header file, and we're going to include that there. And the reason we've included it here instead of the source file is simply because we want all of the information that's in here, be it the structs, any other data structs we may add, or other data types, as well as all of this. We're going to want to know about it. I do understand we could get away with putting it in the source file. However, for this purpose, I'm putting it here in the header. So to get things started, private. So as I was mentioning, we need to use a GUID, well, we want to use a GUID to identify our actors. Well, in Unreal, you have the F GUID, just because it uses the Unreal formatting of F. Now, with that, because we know these are unique identifiers, nice thing we can do there is use that as the key in a map. So I'm going to go actually T map F GUID, and then we have F save actor data. Now we could have done, as I was mentioning, we've done in other things like struct F save actor data, but we don't need to because we actually know about it courtesy of the include that we had. And this is going to be savable actor data. Now, some other information we are going to need in here. We're going to need a pointer to a save game. So we're going to go class, and actually I'll just show you in here. It uses a slightly different format. It's your save file name. So grab that. Pointer save object, actually save game object. We want to have clear naming. another thing, and this is going to be dependent on your game. If you only want one save game at a time, that's fine. You don't really need this next part. But if you want your player to have multiple saves, then you're going to want to do this part. You're going to want something along the lines of an F string save game name. And for this, I'm going to be providing a default value here because I don't want there to be an exception, because at some point I forgot the code or forgot to set a save name. And then another one is if your game has multiple levels or say sub-levels, think Skyrim, Fallout, how whenever you go into an interior cell, it loads up a new map. If you're going to have something like that, you're going to want to know what map you are on as well. So F name, just because that's how level names are used within or referenced within Unreal Engine as a name value. Currently loaded level equals default. And actually for this, because we're not loading a current level, let's put that as none. So right here within the game instance itself, this is the basic information we're going to need. Now you're going to want this information also in your save game object. So we can actually do this pretty easy. We're going to grab that. We're going to go to our save game, private, and I'll show you about using that struct here. And then we're also going to want to store the currently loaded level. And so with this, to explain the save game object, actually, as we're here, the save game object is just a utility class that the Unreal Engine uses, and it will automatically saves all the information that's stored in here with one key point that's required. All of these need to have a uProperty decorator. Doesn't need to have anything in there for attributes, but you do need that uProperty decorator. So we'll actually clean up the save game class quickly because this is really simple. So we have the ability to put the information in this object. However, public. I'm typing, reading, and talking at the same time. My brain does not like triple tasking. But anyways, so with that, we have these data objects or variables within the save game, but we have no way to access them. So it's actually pretty simple. We have 4 functions we're going to be adding to this class, and then we're done, at least for now. So we want void set save actor data, and that is going to take a map, and we're just going to call that data. We are going to have a get a save actor data that has a return type of that map. We are going to have a void set current level, which takes in an F name, const F name, not going to use a reference here, level, and we are going to have a F name get current level. We're going to quickly define those. Now we are going to need to add that include to the source file. Oh, which one am I missing? Oh, get save actor data. Okay, so we want to grab this include here and add that into the source file just so we know about that. Get rid of that. So this one is very simple. So literally savable actor data equals data, return savable actor data, currently loaded level equals level, and return currently loaded level. So really this is as simple as the save game needs to be. Now, if you're wanting to include additional information in here, so you want to include save specific configurations, things like that, you would include those in here. You would either include them individually as each configuration item as a line item, as a struct, however you want to do that. But that is going to be dependent on your game. Well, I will say later on in the series, we will be getting to doing things like game level configuration. But I'm trying to run through things as we're going. I'm not trying to go, okay, here's my entire save game object, because, well, most of it doesn't make sense right now. So, or wouldn't make sense in the context of what I've already showed. So for now, anyways, we are done with the save game class. We're going to close out of that. We do still need to do some work on the save actor interface, but right now we're going to do more work within the game instance. So as I mentioned, the game instance itself is something that's created when your game launches. If you do need to have anything like you want to see, okay, what save games already exist, things like that, you're going to want a constructor. TF game instance. And in this constructor, that is where you would do things like, okay, the game started up, we want to look at what save files already exist, things like that. There is a couple other additional functionalities we're going to want to add in here. So specifically around that save game object, you do need to create the object to write the information to it. So we're actually going to have a function void, wow, I can't type, void create save slot. And the other thing we need to do is we're going to need a couple of different ways actually to populate this data. So running through that quickly, you're going to have a situation where, say, you have going back to my harvested tree, you're going to have a situation where your tree's been harvested and it wants to make sure that that's passed through. So you can have logic that, okay, tree's been harvested, pass off to the game instance that you've been harvested, and then the next time it's saved, it's stored. You can have things where on actor unload, so you move far enough away from an object that in memory it unloads it. So what you do is you pass through certain bits of information to your game instance then, so that when the object comes back in, again, you're thinking open world here, things like that. But then also you have, like, let's say quick save, somebody hits F5, you want the game instance to be able to go through and grab all the information then as well. So we're going to add in two functions here. One is going to be a private function that is going to be used for things like quick save. So it's going to be void gather actor data. But then we're also going to want to add in a public one, and we want this one to be callable by or accessible to blueprints. So U function blueprint callable void add actor data, and we want it to take an fguid and an fsave actor data, actor ID and actor data. Now, as I was just mentioning, we also want a way for an actor to be able to pull its information back out. So we want an fsave actor data, get actor data, fguid actor ID. Now, GUIDs are actually pretty long, so we want to include references to these. And we're not actually going to be changing in either case, so we want const and const. So we have some of the basic stuff here. We have the ability for an actor to add its information and to pull its information. we're creating a save object and we're gathering the actor data. So before we go any further with more functions, let's get these created, and we'll actually add some functionality to these two. Well, 4. Oh, and I just noticed I missed something. We want this get actor data to again be accessible to blueprints. So create that definition quickly, and we're going to go through and create some of this logic here. So we'll start with create save slot. This one is actually a pretty basic and simple one. We have our save game object, which at this point is just a, actually I put a null pointer on there. No, I didn't. We want this to be initially created as a null pointer because we haven't created anything, and there's actually going to be some additional logic we use that checks this. So, but anyway, save game object is equals cast to a UTF save game, and actually we're going to need to include that header. It's going to complain about being an incomplete data class. And then we want to use uGameplay statics, which we need to include the include for. And this one is Kismet. Kismet. Wow. Include Kismet gameplay statics. uGameplay statics. Create save game object, UTF save game object, static class. 1, 2, 3, 1, 2, 3. All right, so that really all this is saying is create the save game object, and this is the class we need to make. Oh, and actually, one thing we need to do again. So as you can see, we want this to have a U property. Otherwise, garbage collector will clear it up. All right, so this one's pretty easy. And then both the get actor and return or add actor are pretty easy as well. So this one, we're just going to go save a bull. Saveable actor data, give it the key of the actor ID equals actor data. Now this is something that is unique to maps. Basically what we're doing here is, or if you're familiar with C#, it's a dictionary, is the closest comparison. We're adding in a key value with the actor ID and we're setting it to this. And what'll happen by default, if this isn't in there, it creates it, it adds it. So we don't need to do any, is it there? If it's not, create it. This will just go, okay, if it's already in there, update it. And if it's not, add it too. So, and then we can go return. Actually, we just copy this. Is that going to work? Just wait for that to load through. That should return the data for that one. So let's just do a quick build to make sure. And I'll just pause while this is built because I know this episode is starting to run on. All right, so I actually canceled the build process because I noticed there was some errors being thrown, specifically in save game. So apparently, and again, this is my mistake, it does not like, let's go back to that first one in here. It does not like the incomplete class of the fsave data actor. You can see it's in here on line 15, doesn't like this. So this was a mistake on my part. We do need to include this reference in our save object. So we're going to put that up here just before the TF save game got generated. and we can go through and clear the use of struct within these definitions, or declarations, I should say. So we'll try building this again, and if there's any more errors that come up, I will again stop and come back to you right away. And we're back again. This one just happens to be a really stupid mistake on my part. We have the constructor defined here in the header, but we don't actually have it in the source file. So UTF game instance. So let's try this one last time. They say third time's a charm. All right, so again, I'm going to pause and as soon, oh, there we go. It's done and it's built. So fixing a few of the mistakes I've made. And with that, again, that goes to show why I'm always saying build frequently. It saves you doing a ton of work and then not knowing what did I do that's causing these problems. So anyways, so we have all of this in place here. Now, the one other function I'm going to run through quickly, and this is after that we'll end the episode there because this one gets a little long, is this gather actor data. So with that, I'm actually going to add the include right away. We need to include engine utils for a particular data type we're going to be using here. So now with the gather actor data, we want to have a for loop, because what we're actually going to do is we're going to be iterating over every single actor that is currently loaded. So f actor iterator it, and that is going to be get world, and that's how we're going to be going through and grabbing every actor from the world, and we want to increment that as we go through. So now we don't need that semicolon in the end. So what this does is it gets an iterator, well, it's an iterator that is going to go through literally every single object in the game world. You may think this is overkill, but it's actually surprisingly fast. I've actually tested this with, I think it was 50,000 actors, and of those 50,000, 22,000 of them had save data. Now, a lot of those were just debug actors, but it was incredibly fast. So we want a actor, and we want this to be a pointer to the iterator. So now, first thing we want to do is actors can either be in the process of garbage collection, which means they've already hit the point in our code logic where it's like, okay, actors unloading, pass your information off to the game instance. If it's hit garbage collection, we've already done that. So we can go if not valid, well, not is valid, actor. And what that'll basically do is, okay, so this actor is already in garbage collection. The other thing we can do, and this is why we're using that save interface, not actor implements you save actor interface. So what we're saying with this particular statement is if we're in garbage collection or the actor doesn't use our save interface, we just want to continue on to the next. So in the case that it does, we want to go I save actor interface pointer inter equals cast to an I save actor interface actor. So what this is doing is this is just basically saying it doesn't matter what class this actor is, we're just going to be using information that we can get from the save actor interface. Then what we can do, and this is just a fail-safe. How was I doing this? Oh yes, that was it. If enter equals a null pointer. Now this particular use case should never happen. However, it is a precautionary just in case. Because, and just to explain why, right here, this particular check should mean this is always valid. However, I throw this in as a precautionary because sometimes, in extremely rare circumstances on a really powerful machine, this could be valid, even though it's not. I don't know the full details. I've seen it happen like once in I don't know how many times, but I add this in, as I mentioned, just as a failsafe. So this is where we would need to go through and start accessing the save game interface. We've gone through, we've found the actor, it's got that. So I'm just going to run through some basics here though, because next episode we're actually going to expand on that interface. So we're going to have fguid act ID equals, and this is just an example for everyone, so we have a rough idea. Enter get actor ID, and then we're going to have f save so this is just something very basic to try and run through this quickly with everyone to explain what's going on. So what we're going to be doing here in the next episode, we're going to, as we've already started, go through the world actors in the world, go through each and every one of them. We're going to cast them to an actor because again, everything's an actor in Unreal in the game world. If it's not valid or if it doesn't implement the save interface, we don't care about it. And it's actually this part right here that is what makes it so fast using this process. And then we've got a reference pointer to our actor, but we're treating it purely as the save game interface. We don't care about any of the actor specific functionality. We're only using the save game or save actor interface functions. And then we're going to be getting the additional information here. Now, the actor ID one, plain, simple, straightforward. It's actually this get save actor data that is going to be a little more complicated. Now, before I end the episode, I do want to give credit where credit is due. This particular save game is from a tutorial provided by Tom Loomis. Let me just make sure I've got the right one here. I don't want to be referencing the wrong Tom Lumen. Sorry, I am very forgetful. Let me just pull this up here and I will make sure to give full credit where credit is due. So here we go. This is, let's pull over just this here so you don't have a bunch of other stuff that's not relevant. So this is the tutorial that this was all based on. I have done some additional changes over and above this, but you're going to see here like a lot of similarities. And like I said, full credit to Tom Lumen. This is derived from his work, and I can't take credit for any of this. So, hey there, folks. So in the last episode, we started the setup for our save game functionality, and we ended off here with our gather actor function, and we were just getting to the point where we needed to start pulling in some information. So with that, though, as I had said, we do need to cover the specifics of the save actor interface that we created, and we're going to do that now to start with. So let's go over to that interface. Now, for anyone unfamiliar with Unreal interfaces, we don't do any work in the U save actor interface. We do it all in the I save actor interface. So first things first, we want all of these to be public. So everything is going to be down here in the public section. Now, because we are going to be exposing all of this to blueprints as well, we do need to take that into consideration. So there is a slight change in how we're going to be formatting this functionality compared to what we've done so far in the series. So first of all, we're going to start with, let's go back to game instance, this very first function here of get the actor ID. So what we need to do here is U function. And this one we're actually going to call a blueprint native event. And what that means is the function we declared directly below it is something that is going to be implemented through blueprints. And in this case, it's going to be an fguid get actor save ID. That's all we need to do there. Now, we do need to expand this so that it, I shouldn't say expand it, we need to effectively duplicate this so that we have the same thing at a C++ level. What we're going to do here is virtual fguid get save actor ID, but then for the purpose of the Unreal Engine compilation and editor, we need to do something slightly different, and it's underscore implementation. And what this does is it tells the editor that this is the C++ version of the call, and if we're using this, we're using the blueprint version of the call. So that is the first one, that is get save actor ID. And as I mentioned, we do not need to do anything with this blueprint one, but we do want to add some basic information for the get save actor ID information. We want a default. And what we're going to do here is fguid ret equals fguid. And then we're going to go ret.invalidate. And then we're going to return ret. So the whole reason we're doing this is this is the default function. If your the actor that you're using this interface on doesn't have this function defined, it's going to fall back to this. And we don't want it providing a valid GUID. So now the next thing we're going to want to do is we are going to want to cover the get save data function. So we're going to again go back to the save actor interface into the header file, and we're going to do basically the exact same thing here. We're going to go U function blueprint native event f save actor data get save data, and just like before, virtual f save actor data underscore implementation. Casing is important here. Implementation. There we go. And we want to do the same thing here, except we don't need to make sure the data is invalid. We just want to return the default. So that right there is all we need to do. So now we have these two functions. We're going to actually want to add this interface onto our base character class. So we're going to go to tf character header file. We are going to want to grab the include save actor interface header. Let's go back to the character file, put that in the right place. And we're going to throw that in there. And for this, sorry, brain fart for a moment there. So for this, we want to go add public iSave actor interface. And what this is going to do is this is going to tell the compiler that this class uses the iSave actor interface. So anything that we have at a game level running with, well, any base class from here, and that includes a player character, is going to have this interface. So what we want to do now is we need to add these in as functions within this class. So the first thing we want to do is in here, we want to go back to our, we want to grab this and add it to here. And we want this to be public again because the functions within the interface itself are public. These need to be public as well. And as I mentioned, we don't need to include this because we're doing it at code level. So we want to use the implementation method. And we're also going to add in a get save data implementation. So with that, first thing we want to do is go to, sorry, give me 1 second here. I'm just looking at my notes on this one. I want to make sure I'm getting this information right. Okay, so the first thing we're going to want to do is we want to make sure this actor has a GUID. What we can do is up here, and I broke my own rules there. So anyways, so we want to go U property, visible anywhere, blueprint read only, because we don't want this to be changed. And we want to go F GUID save actor ID. And then what we want to do is over in the source file, as part of the constructor, we want to go save actor ID equals F GUID new GUID. And then literally all we have to do is back in here, create a definition, and return save actor ID. So now what this is going to do is whenever you put a copy of this actor into the world, it is going to generate a GUID for it. One other thing I like to do is as part of the begin play, I add this in as if save actor ID dot is valid. We don't want to do anything. We want, if it's not valid, we want to and what we've done here is this is just a precautionary fail-safe. If for some reason this line of code is not executed, we're going to give it a GUID when we begin play. Now, I was initially concerned that maybe you're going to run out of GUIDs, but as we've seen in the last episode, there is such a large number of GUIDs, the chances of that happening are minuscule. So the next thing we're going to want to do is create an implementation for the get save data. So in here, we're going to go F save actor data ret. Now I just use the name convention of ret as short for return, and then that means well, and that's just because it's easy to keep that consistent across all of these functions. So ret dot actor class equals this. Where's this pointer? Yeah, no, there's a pointer. Get class. Returns to the U class. Yeah. And ret dot actor transform equals this dot get transform. And then this is also where you would put in any additional data you may want to add. We don't want to do anything with byte data yet. That is going to be covered at a different point. Now, there is that one other value here, was spawned. So we don't have any way of storing that. So what we're going to do here, no, that's because we don't have that in there. We're going to also add in bool was spawned equals false. And ret dot was spawned equals this dot was spawned. So right now we've got this basic information here. So from that, we are able to now continue with this logic. So for that, our next step here is going to be fguid save actor. Actually, I'm going to shorten this one. Save actor ID equals enter get save actor get actor save ID implementation. And then if not valid, so if this is an invalid GUID, we just want to continue again. And the reason for this, and I'll just explain quickly, is every time we hit a point where something isn't valid, you can do something like add logging here to say we pulled an actor with an invalid GUID, and that's up to you. I'll be doing that later on in the series when I get to the logging section. But the whole purpose of these checks are, okay, is this valid? No. Let's go back to the next one. Same thing here. Is it valid? No. Back to the next one. It helps speed things up so that you're not wasting time processing a lot of additional information before you realize your information is bad. Like we know at this point, if it doesn't have a valid GUID, we're not going to be saving it. So just move on to the next one. Now from that, we need fsave actor data. And I'm just going to call that sad. And that is actually going to be equals enter get save data implementation. Now this is where, as I mentioned in the last episode, we're following that tutorial from Tom Loomis. This one is where we're going to start populating that byte data. And the reason we're doing it here instead of within the specific actor itself, like in here, is for the purpose of we don't want each individual actor knowing about everything it needs to save, things like that. We're going to bloat this class, and it's going to add a lot of like unnecessary overhead to the base character class. Whereas if we add it to the game instance, we have to define it once, and it's only sort of in memory once, and ultimately it helps just reduce the overall memory footprint. So anyways, going back to this, we do need to add a new include in here, and this is a bit of a weird one. It's pulled again, like I said, directly from that tutorial. It is the serialization object and name as string proxy archive. That's a mouthful. I'm not quite sure why it's named like that, but so down here we need to establish an f memory writer. And we're going to call that mem writer. And we want to instantiate that using the byte data that's in our save actor data. Actually, I'm going to move this into its own line so we know it's a slightly different section of code. Next, we are wanting to grab an f object name and string proxy archive. We're going to call that AR for archive. We want it to be instantiated with the memory writer. And we want it inload if find fails, we want true. Next, we want to define a property. So AR is save game. We want that to be true. And what this is basically saying is any property that has the save game attribute. Now, we haven't defined any of those yet. We're going to do those in a moment. So once that's done, we want actor serialize AR, and then what this does is it's going to grab all of the savable information, serialize it for us, and actually push it back into the byte data of your save actor data. Now the last thing we want to do is savable actor data. What would I call that? SAI, save actor ID, equals save actor data. Now, normally I don't like using these acronyms. However, the descriptive name is very long in this case. So, and ultimately, that's the basics of the gather information or gather actor data. So now there is going to be certain things in here that this isn't going to catch. And that is where I was mentioning how let me pull that back up. In here, you're going to want to potentially add in some additional storage data. And again, the whole reason for that is because there is certain things in here that are not going to be saved by this process. So now, before we get too carried away, let's just do a quick build here. Make sure all of this works and I don't have any code errors. And this is going to take a moment, so I'm going to pause and I'll be right back as soon as this is done. All right, that build's finished. Took a little longer than expected, but we are good to go there. So now this is just the basics of the save system. As of right now, all this would save is our player character's location or transform. None of the other information would get saved. What we need to do is start defining some additional attributes that need to get saved. Now, those can be saved by, so here we want to go save a game. We want to add this particular attribute to our U properties. So, and what that is going to say is, was this spawned? It's going to save whether it's true or false. We don't really need to save the save actor ID, but just in case, we will. We're going to add that to our stat line component. Oh, the parsing is going through. There we go. Now we're going to go also into the stat line component. This, however, from my personal experience, isn't going to save anything, but we will add these in just in case. And then close out this struct. In here, we want these to be save game. And that should be all of them. So what we're going to do, though, is we're going to need to add some functionality into the game instance for, at least quickly, that is going to allow us to actually test this. So what we need to do here is add in U function blueprint callable void save game. Actually, I'm going to do this the other way around. It's dev save game. And that is just something I've added in as a development call. And that is a perfect reason for this prefaced dev. Actually, I'll do that. So we're going to quick action and refactoring, create a definition. So what we want to do in here is, let me just pull up how I had this before. Again, I'd prefer to keep my notes, so I'm not, or looking at my notes so I don't mess up anything. So in here, this is if save game object equals null. And this is that null pointer checking I put in before. Save game. Nope, we have that create save slot. And then we're going to call gather actor data. And then we're going to go save game object. Add save. What is it? Save actor. Set save actor data. And that's savable actor data. We're not going to worry about the current level, but that is something you would want to do. In here, you'd want to set the current loaded level as well. And then you want to call U gameplay statics save game to slot. You want to pass in your save game object, save game name, and then the user index. And again, for a single player game, you don't need to worry about things like the user index. It will always be 0. All right, so now we've got that. Let's build this quickly. This shouldn't take too long to build because we've only added a couple things, but apparently it's taking 13 actions. So we did add all the save game tags. So I'm going to pause this quickly, and as soon as this is back built, I will be right back. All right, so that's built. We're actually going to run the editor from Visual Studio this time because we do want to add a breakpoint in here for when we call this save game function. I just want to actually check. Yes, I made that as a blueprint callable function. So I will be back as soon as the editor's loaded. I know this can take a few moments to load up, and we will move on with the next step. All right, folks, we're back here in the editor. So there is one more thing we need to do before we can actually get this all set up. So we bring the content browser over when it decides to wake up. There we go. No, not going to let me move it. There we go. So in here, we're going to go into the third person folder. Actually, no, we're going to create our own folder. So in this case, underscore GCG for Gas City Games. Open that up. And in this case, the project name, which is the fall. Blueprints. Oh, come on. New folder. Game. So in here, we're going to blueprint class. All classes, TF game instance. Select. Now, one of the reasons for this is later on when we are doing level loading, I have found at a C++ level, the level loading code just doesn't work. You need to do it through blueprints. It's actually been a reported issue to Epic, and I still haven't seen it being fixed, but we will see. Anyways, game, actually, let's game instance. So we're going to save that, and then edit, project settings. Come on. There we go. Game instance. And we have it here, BPTF game instance. All right, so we're going to go back to the third person blueprint. And we are just going to add in a debug functionality here once this loads up for calling that save logic. So key down, keyboard events, sorry. Keyboard events, and we're going to use 7. That's num7, f7, 7. So what we've done here is when we have pressed the number 7, which is the key above your Y/U, not the numpad. So game instance. Anim instance, get game instance. We're going to cast to TF game instance. I'm going to convert this to a pure cast because we have already defined that. And we want to call the dev save game function. So I'm going to do that. Now what we're going to do here before we go through and actually hit this key, move this out of the way, go back to Visual Studio quick, just make sure all of our breakpoints are in the right place. Game instance, yep, we have this here, so we should hit this breakpoint once we hit the number 7 key. So let's play. All right, so we're in game. It's a little clunky. So 7. There we go. We've hit this breakpoint. So you can see, so that's null. It's going to go into the create save slot. Object is null. Now we have a game instance. Sorry, save game object. Now we're going to go into the gather data. So for f-actor iterator get world, we'll just step through some of these. So the actor here is world info. If it's valid or it doesn't implement that, skip over it. It's a brush. It's a cube. Actually, let's add a watcher so we can make going through this a little easier. So we're just going to step through. It's cube 4, cylinder 13. And then what we're going to do, just for our own instance, I'm going to throw a breakpoint there and hit continue. So now you can see it has pulled up BP third person character because that implements the save actor interface. So I'm going to cast, enter is valid. It's not a null pointer. Okay, so you can see before we do anything, it's all zeros. And now it's got a GUID. With the player character, we're going to be changing this logic a bit. Just simply because the player character is going to be something that is 100% always spawned at runtime. So this GUID is always going to be changing. Like you can see here, it's 385F is the last few there. Okay, and then save actor data. We can push out 11 in here, go through. It's not going to give us the ability to step through anything here because it's an interface and it's going through its first iteration. Second iteration through, we can look at this and go... Is it going to let me? Nope, we'll have to do it when we get back into here. So you can see for that, we have the actor transform. It wasn't spawned, and we can have actor class, BP third person character. Okay, and of note here, just notice byte data is empty. So we're going to go through, create the memory writer, do that, assign that. We're going to serialize. Now let's have a look and see, is there anything else in there? Well, now byte data has a lot of additional information in there. And honestly, I'm not going to go through all of it because there's a lot there, but you can see it's added a bunch of stuff. Some of the information like stat line, object property, so on and so forth. So now we're going to hit F10 just to go through one more. And now we've actually hit one of the mistakes I made in the code. And hitting this reminded me it's not that this was not planned. This is me being a C++ developer by trade. I was using default C++ logic. What we have done here is we're just assigning. It's already empty. With Epic, or Unreal specifically, you actually need to add. Save actor ID, save actor data. And this is something, again, like I said, this is one of my mistakes. I was using normal C++ logic with mutable maps. But because this is a Unreal specific T map, you can't just push stuff in. So we have to fix that, which also means we need to fix it in save game. Nope, that wasn't save game. It was the add actor. Where is it? This one here. Dot add. Actor ID, actor data. So, all right. So now we've fixed that. Let's build this again. And we'll continue debugging through all of this. I'll throw a breakpoint there just so it's, when we're going to add it, I can hop through to that quickly. This built really quick because it was only a very minor change to the game instance class. Hopefully this actually launches the editor quickly. We'll see. And there we go. Launch that pretty quickly for a change. Quickly check to make sure is that logic still there. Yes, it is. So close out, play an editor. Go move over here. Let's run up here and hit 7. So we're going to go through save object is null. It's going to create one. Gather actor data. I'm going to just jump through to the continue. And in this case, we can see the actor is BP third person character. Let's go through and get that. And here you can see that GUID is different. And the reason being is this was the player character spawned at runtime. It's not an actor you take possession of in the world. With that, as I mentioned a little later on, we are going to be fixing this logic so that it is always using a specific data store for the player. But right now, we're just going through the basics of the save system. So we've got that. Let's just continue to this next one. So savable actor is empty. Now it's got one actor in it. So we're going to hop out. No, not letting me do that. Put that one there. So continue. So we have gathered that. Savable actor data. There's one in there. Save game object, set save actor data. Push that through. And then we're going to save. And there we go. So we have saved that. Well, we don't have any load functionality, but that's a start right there for showing how the save game system works. Next, we're going to add in that load functionality. So close out of this, and actually we're going to shut down the editor. So now for that load functionality, and that's actually going to be the last thing we do here in this episode. We do need to add a new function to the game instance. Sorry, just what we're going to do is add this as a private function, void load game, and create a definition for that. And this one, the reason being it's a private function is we only want to call this when certain things have been set, like the level name and everything like that. Oh, sorry, the save game name, not the level name. So what we're going to do here is if u gameplay statics does save game exist, save game name for user index 0 and not bracket. And we need to close that out. And just like everything else, we're going to put a negative. If it doesn't exist, we want to just return. And in here, we'd want to go to do add logging and error message about missing save game. So now that we know that that save game exists, what we can do is load that information. So with a loaded game, you want to make sure none of your potentially previously saved information is retained. So what we need to do here is savable actor data dot clear. Or is it empty? Empty. Remove all the elements from the map. Yeah, sorry, dot empty. And what that does is that clears any information that may have been stored on your game instance, and resets everything there. So next we want to go save game object equals cast to UE5 save game U gameplay statics load game from slot, and it's the save game name for user index 0. Next, we want to pull out that information, so we're going to go saveable actor data equals save game object and get save actor data. So again, if you're using multiple maps and things like that, you'd also want to in here call get current level load current level, and you'd want to do things like that. So now the next thing we need to do is actually, then there's going to be some stuff we're doing here that's not critical right now, but it's better to get this in place now than wait until later. So what we're going to do is for t-tuple fguid fsave actor data side in savable actor data. So what we're doing here is we're iterating through every single instance in that saved information we just loaded. And what we're going to be doing here is if that saved actor data value, so that's pulling up the information from the save actor data itself, not the tuple, not the key, sorry, and then was spawned. So what we're doing here, this is for, as I've mentioned before, the spawned at runtime actors. And there's a reason for this. I will cover that shortly. It's better, going to be easier for me to explain that after I've done this. So a actor pointer spawned actor equals get world. Helps if I could spell world. Spawn actor, and we want this sad.value dot actor class static class, and then we want to use the sad.value dot actor transform, and that's going to put it in the world. Oh, what are we doing? U class, what am I missing here? The value actor class, static class, that part's right. Oh, that's, yeah. And that's because it takes a pointer to a constant F transform. And then I want to go I save actor interface pointer enter equals cast to I save actor interface, and this is logic we're going to be adding in the next episode. I just want to add this now. Spawned actor, thank you, if enter no pointer continue, otherwise call set actor good. There's a reason for this, and like I said, we'll cover this in the next episode, but I just didn't want to miss this part. So now we've done this, the next thing we're going to do is pretty much the exact opposite of what we did in the save logic. Instead of getting every actor in the world, and if it's saved using the save interface, we're going to pull the information from. We're going to get every actor in the world, and if it's using the save information, the save actor interface, we're going to push the information to it. So for that, we're going to go for f actor iterator it, same as before, and then it's get world, if I could spell world, it, and increment it. Increment it. I can't even keep my casings consistent. And I'm using, it's been a long day today. There we go. So, same as before, a actor pointer actor equals a pointer to the iterator. If is valid, actor, or doesn't actor implements save actor interface. We're going to continue. And this is one of the things I had done that I actually didn't like. I wanted to refactor in my previous attempt. So if saveable actor data dot find, nope, sorry, I missed a step here. So save actor, save actor interface pointer enter equals cast. Actually, I'm just going actor if enter equals null pointer, continue. So now, as I was saying, if this is one of the things I wanted to refactor, so I'm going to use the new method I was working on. So if save actor saveable actor data dot find wow, I'm really not with it. fGUID dot save actor ID equals enter dot get actor save ID. And so this right here is the reason why we are going to be calling a set actor GUID. If not savable actor data dot find sad. So this is one of the things I was iterating in my previous attempt. I was iterating through every single one of these to see if it matched. Where this, it's actually a quicker function doing it this way than doing the iteration that I was. So let me just do this. So now that we've found that, we know the savable actor data contains this particular actor's information. We can now apply some additional information. So we can go f save actor data sad. Nope. Save actor ID. Fix this. Equals savable dot and I just hit the build button, cancel that. I say aye. So we know it's in there. We can pull it out at this point, and then we can go actor dot set transform sad dot actor transform. And now we want to do the opposite with that memory writer. We want a memory reader. So we want f memory reader, mem reader, sad dot byte data. And then we want f object name string proxy archive ar mem reader, and again true. ar.ar is save game equals true. Actor serialize ar. And then this is also, I'm going to add a comment in here. So it's at this point, if you do have any data that's not being correctly saved with the save logic, you would call that functionality at this point, because all of this other serialized information has been applied. And at that point, that's the end of this for loop. It will go through to the next actor and rinse and repeat. And again, like I said, through my testing, this still is incredibly fast, even with like 10, 20, 30,000 actors in the world. So now we have added this functionality. I'm going to say I'm going to call this episode here. It's already hit pretty long. Actually, no, I will finish this off. I'm not going to leave you guys on a cliffhanger. So let's add in another dev function. Game instance, blueprint callable, void dev load game. We'll get this finished up and then I'll end the episode, because I know I hate when you get a cliffhanger. So for our load game logic, we already have where to go, this part here. It's pulling in that information. So all we're going to do here is call load game. Well, build quickly. Again, this should be a pretty quick build. We haven't changed many files. But just in case, I'll pause this and I will be back once the build is complete. I paused the video and the build finished, so we're good there. Let's launch the editor. Hopefully this is just as quick. It's loading pretty fast, so I shouldn't have to pause the video. Let's just open up the player character again, blueprint quickly, and add in some more debug logic. When this loads, there we go. Oh, come on. Keyboard event. Keyboard event. I'm going to use 9 here. Thankfully, we can reuse this and go dev load game. So simple as that. We're going to compile, we're going to save. Now, just because, as I mentioned with that whole GUID situation, there is going to be an error if I hit load right away. So we're going to run in editor. We're going to hit 7 to save. We're going to continue through to skip that. Skip that. Okay, actually I want to throw a breakpoint there, because I didn't add one there. I'll add one there just in case. Get rid of that one. Get rid of that one because we know that is working. Okay, so that saved. Now let's hit load. So we're going to hit load game, step into that. Save game name is default. Does it exist? Yes, it does. So right now you can see we have one actor in there. We're going to clear that out. It's now empty. We have a new save game object that we have loaded. You can see there is in this object, before we, like right here, you can see this is still empty, but in our save game object, you can see we do have one entry. And now we have one entry here. So this is going to iterate through it really quick. Dot value was spawned false. So I'm not going to do anything there. So next thing I'm going to do is put a breakpoint here. We're just going to continue. So we can see our actor is our blueprint third person character. Step through that. Interface isn't null. Do not directly call event functions and interface. I used the wrong one. So let's go to, that is where we're using the implementation. I made the wrong one there, so let's try this again. Go back to the editor, stop. Let's see if it's going to catch that with live coding. Yes, it did. That worked. Okay, so we'll try that again. So again, we're going to save. It's saved. I need to add some messaging there for that. Actually, I'm going to run over here, hop up here, save, just to show you guys it's actually working. So we're up on the corner of that block there. So we're going to hit F9. Ignore changes. Source files. Yeah. That is just because of the change here. So we're going to hit continue. There we go. You can see it's loaded up that. It was in our saved actor information, so we're going to grab this information. Got our transform and everything. We're going to set the transform, load in the byte data, and there's actually nothing in there. So we're done. We're going to just continue out of here. This should bring us back to the editor, and you can see we've loaded back up here. Now, I just want to check to see, because this was an issue I had in previous games. Our stat line wasn't saving properly. Let's try this again. Hunger and thirst are pretty much gone. So we're going to do that. I'm going to remove that breakpoint. Just continue. Remove that one. Remove that one. And yeah, so that is what I was saying. You can see our hunger and thirst in the top left there. Well, thirst and hunger are now gone. We'll hit load again. None of that information is actually being reset properly. So that is something that's not being saved as part of the serialization. We will need to work on that. But that is something we're going to work on next episode. Thanks for watching, folks. I hope you've enjoyed and learned something. As always, any questions or comments or suggestions, please feel free to add them to the comments. And with that, I will see you in the next episode. Hey folks, welcome back. Last episode, we set up the first parts of our save game system, where we went through and we could save actors, locations, and certain other bits of information. As you can see here, we saved our location, but one thing that isn't being saved is our stat line component information. As you can see, the hunger, thirst, stamina, that is staying where it was. So in this episode, we're going to work on that. And I want to preface this episode with a, well, an admission or just some information, but I know the method we're going to be covering in today's episode is likely not the best method to be using. However, it's the only method I've been able to get to work consistently. I have tried some other methods and I haven't been able to get them to work properly. So with that out of the way, we will get things started. So the very first thing we need to do is we need to actually create a utility class. And what that is that's basically just a similar to a blueprint function library. But it's something we're going to be using at a code level. To do that, come into your C++ classes and then your project folder. And we're just going to work straight from here. So we're going to go right click, new class. And we want none, an empty C++ class with default constructor. or there's even the U object. Bear with me here. I want to double check what method I used in the last attempt before I say that. I believe it is actually the none. So we're going to start with that. And in this case, it's going to be a public class. And I'm just going to TF for the fall in this case, and then utils. And we're going to create that class. Okay, so it does create a few things we don't need. However, that's not a problem here. The header file is all we really need. So as I was running that, running the editor outside, I hadn't launched it through Visual Studio. I'm just going to let things finish there, but we can start working on our code. So the first thing we're going to do is in the source file, we're just going to remove the default constructor and deconstructor and save that. And then we can close that. And then over here in the header file, we can actually remove, oh, we're going to hit reload all. So that actually pulls it in. Close back out of the source. And then the header file, we're going to delete everything but the pragma once and the include core minimal. It's the only thing we need to include in here. So I'm going to close out of live coding, and now that that's popped up, I'm actually going to close out of the editor as well. Just get content browser out of the way if it lets me. Come on. Nope. All right. Well, I'm just going to leave that running. So what we're going to be doing in this class, well, it's not even really a class, it's a function library, is going to be using and creating utility functions. And these are going to be things that are usable in pretty much any case that you want, or any place that you want, and you want them to be used, or they're going to be used in multiple different areas. So this first function we are going to be creating is something, it's a string chop function, chop string. And this is going to be used as part of our, well, actually in this case, it's part of our load functionality, but it's also, it can be used in other places as well. So we want f string source, if I could spell, char split, and I'm going to give this a default value. Are you going to stop? Oh, I can't even use the right casing, or right, there we go. I was using that as a text, not a char. Okay, so tarray f string ret and f string push, and then for int I equals 0, I less than, I want to treat this as an int, source dot length I plus plus. So what we're going to be doing here is we're going to be stepping through each individual character in this source string, and we're going to be looking for this specific character. So if source I is equal to split, we want to take ret dot add push, and then we want to clear out push dot empty, else push plus equals source I, if source, or sorry, if I equals source dot len ret dot add push, and then return ret. So just quickly to run through what this function does, we'll actually just do it up here. We're going to say you send in this string into, like, that is your source string. What that is going to do is it will output an array of val1, val 2, and val 3. And we're going to be using that as part of the save system for our stat line component. And this is something I actually use myself. It's a helper function I've used for quite some time in my professional life with development. Obviously, it's not using the Unreal formatting of T arrays and F strings. It uses vectors and strings and everything like that. But literally, it's iterating through. It's like, okay, if this character is the character we want to split, we're going to grab everything that we have in the push here, add it to our return, and then we're going to move on to the next character, so on and so forth. So now that we've got this helper function put in, we can actually go back to our stat line component here so we can get things working there. So what we need to do is add something to this struct. And that is it's basically a save string function. So it's f string get save string. And this one is pretty simple. Again, like I said at the start, this is not the best solution. I know there's going to be something better out there. However, this is a solution that I have had work for me every single time. So we want f string ret equals f string, and if I get my capitalization right, sanitize float current ret plus equals, we're going to add our split character. I'm going to just copy that because we're going to add that again. Ret plus equals f string sanitize float max. Add in our separator, and ret plus equals f string sanitize float per second tick. And then we want to return ret. And then we want to add one final helper function here into our struct of void update from save. Now you could go two different ways with this. You could go t-array f string parts, or you could pass in just a string and separate it within the function itself. What I'm going to do is just this t-array, because then we don't need to worry about adding in calls to that utility function within the structs logic. We can do that within the source file instead of the header file. So, and right now we know parts should be 3, so we're going to add in a failsafe. If parts.num does not equal 3, to do log error return, otherwise current equals fc string atof pointer to parts 0. Max is parts 1, and per second tick equals parts 2. So quickly, just to run over this. So as I mentioned, we've got our generate save string, and then we've got, actually we're going to update from save string. So if parts doesn't equal 3, so if for some reason we're passing in an array that is 1, 2, 4 or more, or 0 for that matter, parts, we don't want it to do anything because it's going to cause some weird behavior. So we've got the failsafe here. If it doesn't equal 3, we want to log an error once we get to logging, and then we want to just bail. Otherwise, we want to set the values based off this. So those are the changes we needed to make to the struct. now we actually need to make some changes to our save actor data struct. So we're going to go to the save actor interface up to the top here, and we actually need to add a new struct in. So at the very top, just below your includes, go use struct blueprint type. As we know, we want this accessible to blueprints. So struct f save component data. I holding enter instead of shift. Generated ustruct body. As I mentioned before, and I'll just cover it briefly here, generated body and generated ustruct body are both viable. I used ustruct body for code clarity, and that's it. And just like before with our other struct, we want all of this to be public. And again, we want these to be visible anywhere and blueprint read write. So the first thing we want is a T array of uint8. And we want this to be byte data. And we want the same thing. We want U class, component class. And then finally we want T array F string raw data. Now what we also want to do, because we're going to end up having actors that have multiple components. So think your player character, you're going to have, in this case, the stat line component, an inventory component, perhaps a trait component like your skills, things like that. We're actually going to want to add this to our main save actor struct as well. And we're going to add that in right under the byte data. We're going to go T array, again, my casing, F save component data, and we're going to just component data. Yes, I understand I say data weird. I have in my life lived in various different places around the world and have a mongrel accent. It's a mix of so many different things. So anyways, so now we have that added in. We need to make some changes to our actual save actor interface. So we currently have get actor save ID and get save data. We're going to add in a new function, and these are all going to be done in the same format. U function, blueprint native event, the blueprint variant, and then the same thing again with the code level implementation. So we want a brain's not working. Oh yes, so we want a F save component data, get component save data, copy that, and I'm gonna, for ease on my own brain, copy that, create an implementation of that, and save. And then we want the opposite of that. We want a void, oh, we want that to be virtual. Void set component, save data, and that is going to take in an F save component data. And again, we need the C++ implementation of it. And then, let's see. All right, so that is the main ones we need there. So now we're going to go back to our game instance. In here, we need to now add some logic in to gather the component data. And we're actually going to do that right here after we've serialized the main actor information, but before we add it to our save structure. So what we need to do here is another for loop. So in this case, 4, and I'm just going to go auto, what should we call this? So it's actor comp, and this is actor.get components. And what this is going to do is it's going to iterate through every single component that is on the actor. And we're going to want to do something similar to what we did here. So we're going to go if actor comp implements, and that is a usave actor interface. And if it doesn't, we just want to continue. Knowing that it does, and we don't just, actually I'll step back here for a second, we don't need to worry about this is valid being done down here, because individual components at this point should not be invalidated between here and here. So that's why I'm not including the is valid. We're just looking to see, does it implement the interface? If it does, we want to go I save actor interface pointer comp inter equals cast I save actor interface, and this is actor comp. So now we've got that. We do want to just add in if comp inter equals null pointer. We're not logging anything on this, so continue. Otherwise, we want to move on. So now we need an f save component data, save comp data, save component data equals comp inter get component save data implementation. And then we want to go f memory writer comp mem writer, and we're going to go scd dot byte data f object name and string proxy archive car, and we're going to put in the comp mem writer and true. And then we're going to car.ar is save game equals true. And then we're going to go, what are we calling this? Actor comp serialize AR, CAR. And then we're going to go scd dot component class equals actor comp get class. And then, yeah, we're just pushing that back into, what do we call it? SAD dot component data dot add SCD. So what we've done here, just to run through this quickly, is while we're getting the actor information, we are looking through all of its components. If those individual components need to be saved, or in this case don't need to be saved, we just move to the next one. If it does need to be saved, we get a reference to its interface. If for whatever reason that doesn't work, we move on to the next one. Then we have it, then we call get component save data implementation. From that, we serialize everything we can within the component. We push that back into our save component data struct. We add that into the actor's save information, and then ultimately we push all of that into our save array. Now we need to load that information, so we do need to make some changes there as well. So we're going to go to our load game function. We're going to expand this out. And this is something we'll be covering later in this episode of setting the actor GUID. So this is where I mentioned last episode we were going to need to add in some custom logic. So that's what this section is for here. So what we need to do now, pretty much the inverse of what we just did. So we're going to go for auto actor comp in actor get components. If actually, if not actor comp implements I save actor interface, or is it you? Oh, my brain's not working. No, it is the you save actor interface. Continue. Don't worry about doing anything else, just move on to the next one. If it does, we want a I save actor interface pointer for comp inter equals cast I save actor interface actor comp. If comp inter equals null pointer, if I could spell, continue. Otherwise, we want to pull up what I did before. I want to make sure I'm doing this correctly. Because I had some refactoring I wanted to do on this one. Okay, yeah, so just to cover, what we're doing here is we're checking each of the individual components that are on the actor. If they don't need to be saved, we're moving to the next one. If we can't get their interface, we're moving to the next one. So now that we have that information, what we want to do here is for auto saved component data, and this is, what do we call this? Sad dot component data. So now what we're doing is for every single component we have saved in our actors information, we're taking a look at those. And if scd does not equal actor, no, let's go back. fcd dot class component class does not equal actor comp get class, continue. And this is the same thing here. It's like, okay, do these match? If they don't, okay, we don't need to worry about that component. If they do match, we now need to do some additional logic here. So we want an fmemory reader, and this is going to be comp reader, comp mem reader for clarity. And we're going to go, this is scd dot byte data, and then it's f object and name string proxy archive component ar comp mem reader true ar is save, no, ar is save equals true. And then we want to go actor comp serialize car. And then after we've done that, we also need to see, is the, let me just pull that back up so I can reference it, is this information holding anything? So if scd dot raw, is that what I called it? Raw data? Yep. Raw data dot is empty. Well, now we don't want to continue. We actually want to, because continue would go through this again. We actually want to break. And what this break is going to do is it's going to drop us out of this for loop, and we're going to go from here to this point in the code, which is actually then just going to go back through this loop. If it's not empty, however, we do want to now do some work with that. So what we're going to need to do here is get a reference to, we're going to want to add, actually I've done this the wrong way. No, that's right. Comp inter dot set. Is that the one I want? What did I call it? Oh, no, we never added this function. So, no, we did. Set component save data. That's what we want to do. Set component save data implementation, and we're just going to pass in SCD. And then what we're also going to want to do here is break. And the same thing here is that's going to say, okay, this component has got its save information. We're going to go through. Now, there is one thing I want to also address here and fix quickly, because I just realized there's a bit of a flaw here. This is something we'll fix later on. I just want to add this in, and it was actually in my notes from my previous version of this. Let's add it right here. So, my formatting didn't work because my tab indexes are off. So just to cover what this is all about though. So one thing is, if for whatever reason you happen to have two identical component classes on one actor, you're going to have a conflict, and only one of those is ever going to get saved, updated with a save. That is something that realistically you should never have happen. However, it's something to bear in mind, the way this has been done. Now, one possible option is GUIDs. However, you run into the problem with your spawned actors that we have up here. Well, now you're having to set GUIDs for a bunch of different things, and it gets really complicated at that point. So, I have this as a note for myself. That is quite literally not safe if an actor has two of the same components that are saved as the list. First component returned by the actor get component will get all of the data. That's actually not 100%. It's actually opposite. So, but anyways, so now we've got this functionality done. We need to actually go through and update our statline component to correctly handle these. So let's close out of a bunch of these other files that we no longer need. We'll keep the game instance open. Actually, no, we don't even need that. So we need the save actor interface and the statline component. So what we need to do is, first and foremost, have the statline component inherit from the save actor interface. So we're just going to bring that in, copy U, statline component, add that in, and public save actor interface. And now that means we are going to need to include these. So we're just going to copy these over quickly down here in the bottom of the public section. Now you could go through and create a separate interface that's save component interface. However, I wanted to keep all the logic in one place specifically and not have to worry about having multiple interfaces, one for actors, one for components. It does mean a lot of this information is going to be, these functions are going to be useless, but It's not a huge problem on our side. And actually, I just realized I didn't make that virtual either. So now we've copied these over. We can say, well, we don't need these two. So we're going to quick reference these. Quick action refactoring, create the definitions. So we now have the function definitions for those. So let's start working on that. So I just want to quickly make sure I'm looking at the right ones. My old project had multiple iterations of these. Okay, so this one is a little messy, but it's, again, as I mentioned at the start, this is the only way I was able to get this to work reliably. And get rid of that. So we want ret, just like with everything else. We'll just add that in here so it's easy. So ret.component class equals this get class. ret.rawdata.add health get save string, and you can imagine we're gonna have to do this ret.rawdata.add stamina get save string, and I'm actually gonna, for ease, I'm just gonna do this hunger and thirst. Now, something that is important to remember with this is these are all going to be in a very specific order. So that's index 0, not 0, index 1, index 2, index 3, and then this is a note, any additional raw data adds here need to be included in the set component save data notation function. So what this is this is for anything that's not being saved with serialization. And I can tell you the custom structs we created aren't. Anything we add here, we need to add in a similar process here. So now we're going to work on that one. So we're going to want to do this T array F string parts. And no, as I mentioned, this is not efficient. There is going to be a more efficient way for this. However, it's, like I said, it's how I got it to work. Data.rawdata.num I++. So parts.empty. We want to make sure that array is emptied every time we iterate through this. And, oh yeah, this is where we want to include tf-utils. All right, and then we want to go parts equals data dot raw data I actually equals chop string, and though it has a default, we want to just pass that through for ease. So what this is doing is we're taking that and we're splitting it into the individual strings, so that'll be the 3 current, max, per second tick. And then we want to do switch on I, case 0, case 1, case 2, case 3, and default. Case 0 is health dot update from save string parts. Then it's stamina dot update from save string parts. Hunger dot update from save string parts. Oh. Break. Add these in, otherwise it's gonna do some really funky stuff. And thirst. Update from save string parts. Default. Log error with log error, and just want that to break. And then we're done. So what this is doing, actually I'm going to build while I run through this. So what we're doing here is we're taking in, oh, we've got to fail, I'll fix that in a second. Oh, live code is still running because I still have the editor up. I forgot to close it. So anyways, so what we're doing here is we're creating an array of the save strings for each of the stats we're containing. That's getting saved as part of the actor data within the save game file. And then when we're loading it back in, it's like, okay, we've got all this serialized information. So some of this could be, and OBS and my game system just decided to lose a monitor. Either way, so with this, like I've tried, as you can see here, we have that save game attribute. It's not being serialized, and it's up here. It's not being serialized. There is additional functions, like you can do the farchive operator stuff. I never got that to work. So, as I mentioned, I have this working. If I find a better way to do it, we'll update that further through in the series. But okay, that should be long enough for that to build. And I'm going to quickly fix my display. Or not. Okay, well, while that builds, I'm going to pause things here, and I will be back once the build is done. All right, folks. The build completed, but it did throw an error. I did take a couple seconds to figure out what it was. For whatever reason, I'm not sure if this is something unique to 5.4 or if it's something that I did differently, but the error is the fact that we've defined this in the header file. So we're going to quite simply cut that out, turn that into just a function declaration, quick action, create the definition. It's going to take us over to the source file. It's going to define that there, and we're going to build. And this time around, it builds fine. So what we're going to do here, though, before we launch the editor, we're going to throw in 2 breakpoints, one on the get component save data and one on the set component save data. And then we're also going to go into the game instance itself, and we're going to throw 2 breakpoints, one for at the gathering the information about components, and the other one is going to be when we're setting the information about the components. So now we've set those, we're going to launch the editor from Visual Studio or your IDE of choice, and I will be back as soon as the editor is up. All right, so the editor is built. I'm actually just going to move the content browser out of the way, and we're going to hop straight in here. So we're going to go do the same thing we've been doing before. We're going to move our character to a place and hit save. hops into Visual Studio. So I'm going to add a watcher to the actor comp variable. Right now it's been optimized out of the way. Collision cylinder, and I'm going to throw another breakpoint there. So I'm going to continue. Arrow, character move component, character mesh, stat line. So here we go. We're now looking at the stat line. Does it implement the save character interface? Yes, it does. Did we get the interface? Yes, we did. So we're going to get component save data. And now this hops into the other breakpoint we've set. So we create ret. And then we set all these variables. So we're going to say ret.raw data. That's fine. We're going to hop out of this. Now we're going to look here. In the raw data, you can see we have 4 entries. Health, stamina, hunger, and thirst. And you can see it's storing the current value, the max value, and the per second tick. And the reason for that is that we're doing things like the per second tick, things that would be defaults, the max as well, is you could have buffs, you could have status effects in your game that affect those values, and you want those to be present right at the very start. So, like when you load in. So we're going to do that. We'll skip to after the serialize, and we're going to take another look here. And you can see byte data has a bunch of information in there. Stamina, struct, properties, core stat, script, fall, current. It's a float property. And I'm not sure if, but so anyways, now we push that back in there, and you can see we're now going to go through, and I'm actually just going to continue and drop these breakpoints. So we've saved that. Now we're going to go through, I'm going to move over here. Our stamina was almost full. I'm going to bring us over to this corner, and we're going to hit 9 to load the game. Same thing. We're looking at the collision cylinder, and I'm going to put that right there. Arrow, character move component, character mesh, stat line. So does it have the save interface? Yes, it does. And we're going to look in here at the component data. You can see there is one stat line component, actor component. Oh, there we go. That's something I've noticed with Unreal Engine when you're debugging. Sometimes it'll bounce back and forth before it gets to the next actual step. So we're going to deserialize, and we're actually going to look at this quickly before we apply, because we may not actually need this additional information now. So actor component. Under this one here. No. This one. No. Where would stamina and those other variables be? No. Well, in here, I'm not going to waste any more time in this episode digging. So we've gone through here. Is raw data empty? No. So we're going to do that. We're going to hit our next breakpoint. And we've just got that whole struct coming through. I actually need to change this to a reference. parts. So for the first one, I equals 0, parts empty. So you can see parts is empty, and that comes back to, oh, maybe I've got a flaw in here. It's only showing 2, because now we're going to step, oh, Shift F11. There we go. We're only getting 2. What is happening there? So okay, let's see. So I is 2, so we are in the third. So what is not happening there? Parts is only getting the 82 and 100 when it should be getting 82, 100, and minus 2. Okay, that's interesting. So we're going to continue here. I'm going to drop these breakpoints. But you can see the values are returning. I wonder if that's just something with the way things are being optimized. So we're going to get rid of these breakpoints so we can just see that in actual editor. So let's see. Yeah, they are restoring properly. So that may just be something weird with the debugger. But anyways, folks, this episode has ran on a little longer than they expected. With that, we have done the very basics of our stat line and our save game functionality. There is one other change I want to make, which we will be covering in the next episode. And that is going to be, well, not even a change. There's one change I want to make, and there's also one additional item I want to cover. That is going to be uniquely saving the player character's information. And then also, as we glossed over at the start of this episode, or earlier in this episode, we do need to address this functionality here for setting an actor's GUID when we have to spawn one in. But as I said, we'll be covering that in the next episode. Thanks for watching, everyone. I hope you enjoyed. As always, any comments, questions, or suggestions, please feel free to add them in the comments below, and I will see you in the next episode. Hey folks, welcome back. So last episode we added in our custom data save logic. After that episode I did a little digging because we did have that issue where for some reason this function here wasn't spitting out all 3 components. It was only spitting out 2. I actually found a way to refactor this a little better. So we are going to start off with making some changes here. And then we are going to move into the couple of other items I mentioned last episode. And that is game instance. Where are you? There you are. The requirement we have for setting an actor's GUID after we've spawned them in. And just some general cleanup. So first things though, we're going to fix this function. So we do need to keep this return. However, we can get rid of this chunk here. And what we want is F string L side for left side, if I could spell, and R side. And then we want while source dot split, and we want that to be split. We want to reference the left side and reference the right side. I'm unable to hit the right keys today, it seems, or get my case incorrect. And it's complaining about using split. How did I do this? I had this working when I tested it. What do you expect, an F string or a string? Const F string. Split char equals split. Is that how I did it? Can't believe. Get rid of that equals. Is that going to do it? No. Can we just do it that way? Actually, I think that's what I did. Let me just check here. Yeah, that was it. Anyways, so ret.add L side source equals R side L side dot empty. And then if the R side is not empty, ret.add R side, and then return. So just going to quickly build and test this one here. I had this working. I'm not sure why I had to struggle so much with this, but we'll give that a quick test. Throw a breakpoint there, and the editor's loading up pretty quickly here, so shouldn't take too long. All right, let's move that content browser out of the way, and we'll hop in here. Now, as I mentioned in the last episode, we're wanting to do unique player data, and there's a reason for that. And that is, as I've mentioned previously, the player character is spawned every single level. We're not possessing something, so... Anyways, we're going to quickly test this, so let's run forwards. We're going to save. We're going to move off to the side. We're going to run. And then ignore changes. So now you can see with that, we are getting the 3 parts. And it didn't drop in, so let's go into there. I'll drop in. Why are you not wanting to... What do you mean it's not found? It's right there. Well, it is working, as you can see. So I will dig into that, see if there's something weird going on with my setup. But anyways, now that we've got that little refactoring out of the way, and that's something I wanted to address at the start of this episode because it was a general improvement over what I had done previously. The next thing we're going to do here is, as I mentioned, we are going to address this set actor GUID. So what we need to do there is go into our save actor interface, and just like everything else, we're actually going to move this up at the top here because it's a related function. We're going to add void set actor GUID, const f GUID reference new GUID. Copy that, and then we're just going to add the implementation portion there. Bring these back. create the default for that. So we've got this here. We're going to want to add that to our character base. So we're going to open this up. You can see we have the get actor, we have the get save data. We do also now need to add in the set actor. So we're going to add that in here. And I believe that's all we are going to get save. So get actor save, get save data, save ID, make sure we got those, get actor save data. Yeah, so what we are going to be doing with this function is if save actor ID dot is valid, we want to invalidate the current one. And then we want to save actor ID equals new GUID. So what this is doing is because we have both as part of the constructor and the begin play as a precautionary, we're automatically assigning a GUID. What we want to do here is whatever one is already there, we want to invalidate. And then we want to assign the one that's passed through. It's simple as that. So now we can go back to our game instance and we can go, what are we looking at here? This is spawned actor. Nope, we want enter, sorry. Set actor GUID, and this is going to be sad.key. And what we're doing here is we're assigning the GUID ID, well, that's what it stands for anyways. We're assigning the GUID that we have from our save information to the actor that's been spawned so that it's always retaining this same GUID. So that was that minor change there. Now the only other thing, as mentioned, that I wanted to cover this episode is player specific information. And again, the reason for that is we want the player to not be part of this general information. We want it to be directly accessible very quickly because the player is the one character that is across every level. So let's just quickly clean up some of these here. Don't need any of this. So we're going to open the game instance header. We are also going to open the save game header and then also the save game source file. So first of all, in the save game header, we are going to add in a f save actor data variable, but we want u property u property player data. Then we want to add in the relative functions for that. So we want a void set player data, f save actor data, and f save actor data get player data. And we'll just quickly define and create both of these. So player data equals data and return a player data. So that's quite simply the only change we need to make to the save game object or class. So we can do that here. Now back in the game instance, we want to add in a new function, void gather player data. And we also want to add in that player data type. And actually we want to add u property to these so that garbage collection doesn't start clearing these up on us. U property Now, one thing we need to do here is actually, it's going to be in the player character. I forgot this at the start. So we're going to open up the header file and the source file. We're also going to want to grab the character header file just quickly. We want to nope, actually we're good there. So don't need to edit the character file. We do need to edit the player character file though. So we want to go to our begin play function. Player character, begin play. We want to call ATF character begin play. Then we also want to save actor. What are we calling it here? Oh, it's private. That's why we need to move these to protected. Actually, I'm going to clean this up while we're here, just as I've mentioned before, my personal preferences, keeping these in a particular order. And save the file. Okay, so save actor ID dot invalidate. And the reason for this is we do not want this to be a valid GUID. The reason being, when we go back to our game instance, we're going to look at our gather actor data for a second. We have this right here. If the GUID isn't valid, we're going to bail out. And that's going to mean, based off this, we're never going to save the player character. That's fine, because we have added in this particular new function that we're actually going to use as part of the gather actor data. And then we're going to go, what do we... Gather player data. Gather player data. We're going to call this here as part of that. So now we're almost doing the exact same thing here, but what we are doing is we are going to be going u gameplay statics get player character. Yep, there it is. Okay, so we want to ATF player character. We don't have a reference for that. We need that. Game instance. Actually, no, we don't even need to do that. We can just reference it as an A character. A character. And again, so yeah, get world. And again, because this is a single player game, we just need user index 1. And then get rid of this for a second. We need to, now that we've got a reference to that, because we're just treating them as, this is just literally a quick reference, so we can do the rest of this. And you can see here, we're getting just an A actor reference. Well, here it's an A character, but we can just pretty much follow the same logic we've got here. So if not is valid player character, oh, okay, so that doesn't work. So anyways, in this case, we're just going to go to grab this portion, and instead of actor, we're going to pass in a player character, because we want to use that interface for everything. And this is one of the reasons why we use that interface. As you can see here, we're using the player character is of an A character class, where up here everything is an A actor. Both of these work because ultimately we're doing everything through the save actor interface. So if enter equals null pointer. We've got some bad juju. Throw log error and return. Otherwise, we want to, we're not worried about getting the GUID because we know that's not valid. So we just want to go straight into grabbing the save actor data and then going through with the memory writer stuff. So we're going to do all of this, copy that. And there's going to be some errors here because we need to switch from actor to player character. I honestly thought player character was a valid one. So to include, actually I'm just going to do this the easy way, character. Go to definition, character.h in game framework. Okay. Include game framework, character.h. There we go. All right, so in here you can see we've done pretty much the exact same thing. We're getting the raw save actor data, and we're going through doing the serialization. We're iterating through all the components. If the component doesn't use the save actor interface, we don't care. If it does, we're just going through and saving all the information there. And then the last thing we need to do here is a player data equals what we have is the SAD value there, or SAD. And that's gathering the player data. And we now have the player uniquely saved. Now we need to uniquely load the player as well. So we will create another function for that, void set player data, and create that definition. And it's going to be very similar to what we've done with the load function. Oh, where is it in here? The load game, sorry. It is in there. It's just been truncated. So what we are going to do here is pretty much the same thing. It is going to be grabbing a copy of the player character, or a pointer to the player character. We're then going to get the interface. Actually, we're just going to do all of this. And then, sorry, a couple episodes since we've done this, and my brain is completely melting as to what we need to do. It's right here. So we don't need to worry about this portion here because we know the player character doesn't have a valid GUID. We already have this, so we don't need to worry too much about that. But now we want to start working here. So minimize that. So we want player character dot set actor transform to player data dot actor transform. So we've now set them in the right position. Now we need to apply the serialization. So it is what we've been doing before. fmemory reader, pcmem reader, and that's player data dot byte data. And again, actually I'm just going to do this here. Copy and paste. pcmem reader, AR, and this is player character dot serialize. And then once we've done that, we're going into the actor component portion. So we can just copy and paste this. Now, I do understand we could leave this all as using the same functionality, but because player characters respawn like at a code level, the actor is destroyed when you reload the game, things like that. This I found is the best approach. So let's just go through and fix these couple of syntax errors that we've now just created. And that should be all of them. For each of the components in the player character, if it doesn't involve that, we do that. Otherwise, we get a pointer to the interface. We've got that same potential issue here if we have more than two components of the same class. If they don't, we iterate through. If it does, we... Yep. Okay, so let's build this quickly, and we'll see how this goes. And with that, while this is building, I'll actually run through a few things with you guys for a change. So if this is everything's working fine here, which I hope it is, this is actually going to be the end of the episode. This is going to be a shorter one, just simply because I wanted to do the final cleanup on this save game portion of everything here. What we will be moving on to next episode is going to be player interactions. And that's like the player character interacting with the world. It's also going to be used for things like opening doors, picking up items, things like that. And that's the very basics of this initial interaction interface that we're going to be working on. So, built fine. We're just going to launch the editor and make sure all of this... nope, we need to... There's one thing we need to do before we can do that. So close the editor. We set up the set player data function, but we never actually called it. So load game. And some of you may have realized that in the logic, and like, oh, you forgot to call the function. Again, it's why you build frequently and you test frequently. So we go through, and then just in here, we want to add set player data. So we are going to also want to quickly throw in some breakpoints on these two new functions we've added, just to make sure. And for ease, actually, I'm going to, because right now we only have the player character, I'm going to throw a breakpoint there. We should, in theory, never hit this, because it's right after the is it a valid GUID. So let's quickly rebuild and try again. But yeah, anyway, so back to what I was saying. The next few episodes are going to be covering the interaction interface and the basic setup around that. It's not going to be an inventory portion yet. It is just going to be the interaction. That's going to be for things like opening doors and such like. So, anyways, okay, let's quickly test this out. Start the game, is valid. Breakpoint instruction, if save actor ID isn't valid, why are you not? Oh, that's, sorry, we called something when we didn't need to. That's actually, this is a mistake on my part. So begin play, we don't need to call that. Comment that out quickly and we'll try again. And yes, as I've mentioned in pretty much every episode, these are the sort of mistakes that I'm leaving in because, as I've said every other time, everyone makes mistakes. Nobody is a perfect developer. Otherwise, we'd never have a need for more than like 10 or 20 developers, because if they're perfect, they could knock things out real quick. So I want to leave all these mistakes in so everyone can see these mistakes are made. This is how you can fix them. In this example, it's like I just realized, oh yeah, I'm calling a function I don't need to. So Anyways, we're going to let the health and hunger and thirst run down, get rid of some stamina, make sure this is all working. We'll go to our normal spot here. We're going to hit save. Say we're gathering the player data. We have a player character. We have a valid interface. We don't have anything specific for this yet because there's no unique player specific data we've had to add. So this right now is just empty. We've got the actor's location. There's no component data. No, it wasn't spawned. Technically it was, but it's a player character. And we have the class defined. So now we're going through and serializing our byte data. And you can see in here it's added quite a bit. Now we're going to go through our actor components, collision cylinder. I'm actually going to add a breakpoint there just to continue through. The current actor component is the stat line. We have our save component data there populated through with the raw data we need for our stats. So I'm just going to hop through all of this. This should all work fine. Is this valid? Yeah, save actor data. Yep. Okay. And then we're just going to go back to here. So player data is now populated with what we've just pulled from player character. Gather player data. Save game. We missed another step. So let's drop out of that. So this is, again, an example of why you test frequently, you debug, and you throw breakpoints on your code. Because you can walk through and find problems, because like, oh, if we weren't following through the code, like, well, why is the player not saving? Why is the player not saving? Well, right here you can see, well, I never told it to save. So save game object, set player data, and we need to do the exact same thing here. Go to definition, player data equals save game object, get player data. So one of the many things I like to do, and you've seen me do it quite a lot, is the breakpoints, the debugging. It's honestly, and I'm not using this as a dig on other developers, because I understand programming can be easy for some people and not for others. But one of the key skills I found that is, I want to say, lacking in a lot of newer developers is debugging. It's actually my specialty, is going through and finding out where's a problem in the code. Why isn't this working? That's what I do with my career. I fix other people's code. But anyways, so now we've got that. Let's try this again. So let's run forward and just jump a bit. I'm going to park myself in the corner up here. Save the game. Okay, we've got that. Continue. Continue. We've got that there. So we've done that. Okay, we're setting the player data. We're good there. Save game object. All that. Save game to slot. Cool. So continue through here. You can see we're standing right on the edge. Let's go run over here, use some more stamina. And then hit 9 to load. Okay, so set player. Got a pointer to the player character. We've got their interface. There was no errors. And we set their location. We're deserializing the information. And we're going through all of the components on the actor. And there we go, we're on the stat line. Interface isn't null. Okay, we've gone through and we're doing that there. Raw data isn't empty, so we're going to go drop into this. I'm going to drop in here properly. So parts, we'll just make sure. Okay. So I actually dropped in here for a change. So we can see our source is 100, 101 with our separator. So we'll go through this once. Okay, something's not working there. Let's see. No, there we go. It's the same thing I found. Like, a lot of the time, it's not. Yeah, okay, we're just going to drop out of that. So Shift 11. And continue. And you can see we're back up here. I'm actually going to retest this, but it looked like it worked. So we're pretty much equal. 9, let's drop these out, continue. And there you go. Yeah, so everything seems to be working there correctly. So with that, this episode I am going to end here. We've covered the basics and got our save game system set up. As we add new things in, we will be coming back to the save game because obviously, like with our stat line component, there's certain things that don't save properly. We need to add custom logic and behavior for. And next episode, we are going to be starting with the interaction portion. Actually, no, I'm going to correct myself here. Next episode, just because it's in here quite a lot, and it's something I do want to, again, get into the game, into the project early on. Next episode is going to be covering custom logging. And then the episode after that, we will be covering the start of our interaction system. So with that, folks, thanks for watching this episode. I hope you enjoyed. As always, any comments, suggestions, or questions, anything like that, feel free to add them in the comments below. I will try to respond as best I can. And with that, thank you, and I will see you in the next episode.